Hello, everybody. Welcome back to The Doctor Is In, the podcast where we focus on optimizing the indoor plant environment for crops growing in greenhouses, indoor farms, vertical farms, plant factories, containers, and any other type of facility where we want to grow healthy and productive crops anytime and anywhere. I'm your host, Dr. Nadia Saba, president of Dr. Greenhouse. Today's episode, I'm going to be talking about 10 reasons why HVAC for indoor plant environments is so hard. So, number one, let's start with my profession, which is engineers. Engineers don't know plants very well. We're trained in physics and thermodynamics and mechanics, and when we design HVAC systems and mechanical systems, usually we're applying them to office buildings, to hospitals, to homes, to schools, to buildings that have people in them, and usually that is the focus of our design and engineering is around creating a healthy environment for people, a comfortable environment for people, and we're not usually focused on other sort of occupants that might be in the building unless you specialize maybe in animal facilities, or like we do, plant facilities. The other thing is that I'm out on the West Coast where we don't have a lot of humidity, and engineers out here don't know a lot about humidity either. We don't have to deal with humidity so much in our climate, again because we are focused on people. People respond more to, say, temperature settings and what the temperature is in terms of thermal comfort than humidity necessarily, though we all know that when it's really humid outside, we are less comfortable than when it's drier, maybe unless you live in the furnace of Arizona or somewhere really hot and dry like that. And so, because we don't deal a lot with humid environments, both indoors or outdoors, when we start talking about indoor plant environments, not only are we dealing with a different species than what we're typically trained to deal with, but we're also having to focus more on moisture management, or as much on moisture management as we do temperature management. Now, there are some exceptions. I love talking to engineers who are in the southern states because they really understand humidity well. Also, if you talk to people who work in museums or design mechanical systems for museums, they also tend to understand humidity because they want to control the humidity to preserve the artwork, or whatever artifact it is that may be, hundreds of years old or thousands of years old, and the humidity can really degrade that. So when I talk to engineers who are in the South, or who work with museums and preservation, we speak the same language. But that is not, I would say, the most typical engineer. Again, we are usually focused on human environments, on temperature, and we usually keep the humidity out of the building as opposed to dealing with humidity being generated in the building. So that was number one. Engineers don't know plants or humidity very well. Number two is that growers don't know HVAC, right? They're not mechanical engineers, they're not facilities engineers, and we're often asking them to play that role of maintaining and fixing their equipment. I mean, something I love about farmers and farm life and growers in general is that they wear many hats and they get a lot of things done, including fixing and maintaining their equipment. But HVAC equipment is complicated, and there's a lot of moving parts, and there's a lot of things that go wrong. And we shouldn't have to be asking growers to focus on HVAC. They are really focused on, and should be focused on, their plants, right? On managing their plants, on managing nutrient recipes, irrigation delivery, on harvest schedules, on labor, on productivity and quality and insect management. We shouldn't have to be asking growers to be mechanical engineers in addition to all the other things that they're doing that are focused on the plants. Okay, so number three, Plants aren't people. I think this is probably pretty obvious for my listeners, but plants have very different needs than people do. For one, they need light for photosynthesis. They need the right environment for good transpiration and good health and quality in their immune system. They also need to have water delivered to their root system. They have part of their body above ground and part of their body below ground. And, they also, if you think about it, don't have feet, right? They can't go over and change the thermostat on the wall or the humidistat that's sitting in the canopy, right? They're really relying on us to be their voice, to be their feet, and to be their eyes and ears to make the changes that they need to have optimal growth. On that note, they also don't have a voice, right? Like they don't speak to us, at least not in sort of a verbal way. Though one of my podcast guests did talk about hearing her plant screaming or singing, right? Like she could tell when something was going right or something was going wrong. But really, they don't speak, right? And so we have to be the ones who observe for them, who know how to listen to them and pay attention to what their needs are so that we can both anticipate what they're going to need, but also respond to something that may not be working well or may be working well that we want to repeat. So, really, the plants, they're not people, but they rely on us as people to respond and anticipate their needs and wants. Okay, number 4. HVAC equipment is not specifically designed for indoor plant environments. HVAC equipment is really good and it really has been developed over many years, over decades, to perform sensible cooling. And what that means is temperature control, right? Because HVAC has mostly been developed around human comfort needs, and as humans we like a comfortable temperature. That has been the primary driver for developing a lot of HVAC equipment, and that equipment that's really good at temperature control tends to not be as good at humidity control, at removing excess amounts of humidity that we see in an indoor plant environment. One of the reasons I mentioned that I like working with engineers in the South is because they do deal with humidity. People are uncomfortable in that humidity, building materials degrade in that humidity. And so they are more focused on HVAC equipment that can deal with high humidities and remove that moisture. The other thing, about HVAC equipment is that they're kind of slow to respond, right? I mean, if you know that you need more light, you can just flip a switch, right? Whether that's toggling something, changing a setting in your computer, or literally flipping a switch in your greenhouse. We can very quickly change the environment through lighting, even through irrigation. If we see that plants, that there's a hot spot or the plants are getting dry, right? We can immediately water them either through our integrated irrigation system or even hand watering, right? If worse came to worse. But HVAC, on the other hand, it really takes time to respond. We have this thing called deadband where we don't let the equipment, respond to a change in a temperature or humidity signal immediately when, the temperature rises or the humidity rises above the set point. We let it kind of ride for a while to make sure that the temperature is going to continue to rise before the HVAC system kicks on. And then on the other hand, we let the temperature drop maybe below the set point to maybe 1 degree below the set point, so that we're not turning equipment off and on and off and on over and over. For one, it helps to save the equipment that we're asking to control our temperature and humidity. But also, by the time that change is made at the system and gets delivered to the room might be changing again. So we kind of let the room get to a steady state before the equipment reacts to it. And so for growers who are looking for a really tight control, maybe plus or minus half a degree or plus or minus a few percent of humidity, most HVAC equipment just can't do that without just wearing it down and wearing it down to failure within, a very short period of time. Okay, number 5, indoor plant environments are really dynamic, right? I mean, they are always changing. The plants are always changing, right? We talked about how plants aren't people. They don't have feet. They're not going to move from room to room. We usually grow the plants, during their life cycle or during different life cycles, depending on what we're growing. And, in those weeks that they're in a room, they might grow from, a few inches to a foot tall, or from a few feet to 5 or 6 feet tall. They are growing, right? Actively growing from something small to something larger in the same exact position that we planted them or that the grower planted them. And so, right there, we create a dynamic environment because, where the air blew on the plant when it was young versus where the air blows on the plant when it's older is going to be much different. We also know that as the plant is growing, it's using more water, it's using more nutrients, it's transpiring more moisture into the air, and the humidity dynamics change within the room. So when the plants are really young, they might not generate a lot of humidity in the room, and so we need more of that sensible cooling, more of that temperature control from the HVAC system. But then as the plants grow and they produce more moisture, we need to remove more moisture and do less temperature cooling. And so we're really asking the HVAC system to do a lot just within the life cycle of the plant sitting in that same position in the room. And that can be really challenging to find equipment that can manage that dynamic room. That's about plant growth stages, but we also know that growers, right, that they are maybe wanting different conditions in the room, right? They might schedule different temperature and humidity targets when the plants are young versus when they're sort of middle age versus right before harvest. And so not only are the plants, you know, generating a different condition, but we're also setting the room up for a different condition. And so the HVAC system is trying to manage all these different conditions within a very dynamic environment, which can be really hard if you don't find equipment that has a lot of staging or variable components. Okay, number 6. Controls are limited in their ability to manage the environment. This is something that I have been sort of stumping about for 5 or 6 or 7 years. Before I even started Dr. Greenhouse, I recognized, and I think a lot of people recognize, that the controls options for managing HVAC systems in an indoor plant environment is just not there. You have traditional horticultural control systems that were originally developed for managing a greenhouse environment, for managing greenhouse crops, for managing greenhouse equipment, right? And a lot of that equipment, doesn't have a lot of staging. It's not very complicated, right? You might have fans that are turning on or off, or pumps that are turning on or off, or shade curtains that you're deploying and closing. And those are fairly easy settings for a control system to manage. But when it comes to HVAC equipment, commercial HVAC equipment, they have totally different settings and complexities and components that are, internal components that are responding to the conditions that they're trying to control and that are coming back to the unit. And those horticultural control systems just aren't very good at telling that equipment what to do, for one, because a lot of them don't have the communication protocols that the HVAC system speaks. So there's literally a language barrier where the commercial HVAC system might require BACnet or Modbus communication, but we have these horticultural systems that have maybe are used to controlling relays and on off controls that don't speak the same language that the HVAC system speaks. So then, the other option is to go with building management systems. So these systems, these control systems that were developed originally for, say, office buildings or for educational facilities, right, that do speak the same language as the HVAC equipment. But the problem with that equipment is that they don't speak irrigation. They can turn lights on and off. They can dim lights on and off. That's not really the issue. The issue is nutrient recipe management, right? So now we're asking this really sophisticated building system to decide when to, change your phosphorus and nitrogen content, or when to cycle through an irrigation schedule for plants growing at different stages. And that is Greek to those systems. And so there hasn't been a lot of crossover. And unfortunately, there just hasn't been enough development from either side of the controls market, I would say, or the controls development, to manage these two disparate controls needs in an indoor plant environment. And yes, there are some horticultural control systems that are maybe more sophisticated, that are more like building management systems that can do all of those things. But again, they were developed for greenhouses. And, some of their methodologies and strategies just don't fit what we're trying to accomplish in a fully indoor plant environment without sunlight. So, here we are, 7 years later, or, many years later, after, a lot of us recognize the problem. And I would say we still don't have a very good solution. Okay. Number 7, HVAC system startup never represents the grow room conditions. I have heard this sort of struggle from people who are clients or people who are not clients, and maybe it's from the mechanical contractors or from the HVAC equipment providers, that when the controls contractor goes out to start up the system, and all, maybe all the startup contractors are out there, there are no plants in the room, right? And here, as a mechanical engineer that understands, the indoor plant environment and all the dynamics around it, and how humidity is going to change and temperature needs are going to change, when you're trying to start up equipment and test it to see if it can hit your temperature and humidity set points without plants in the room, without that source of humidity, without that source of radiant heat capture that the leaves do through photosynthesis, it's really hard to recreate a grow room condition when it's empty. And so what you hear from growers is that they're really concerned that when the mechanical contractor, controls contractors started up their equipment, that they weren't able to hit their target of, say, 80 degrees and 65% humidity. Well, of course they weren't, because that room started at, say, 30% humidity, and you didn't do anything to add moisture into that room. So there is no way that HVAC system is ever going to be able to hit a target of 80 degrees and 65% humidity, because there's just no moisture to be found. And so all that equipment can do is cool the room and manage the temperature set point. So if you really want to test HVAC equipment at startup, what you really need to do, what we all need to do, is simulate the indoor plant environment, say through adding misters or humidifiers that produce the amount of moisture in the air that we would expect from the plants through transpiration, so that then we can see if the temperature and humidity set points can be achieved. I had one client who called me one time, and he's like, hey, The humidity is just so low, and the unit just can't hit the temperature set point. It can't drop the temperature below 85 degrees, and we ramped up the fan as fast as it could go, and the compressors are all working as hard as they can, and we just can't get the temperature down lower than 85 degrees. I asked this client, I said, "Well, do you have plants in the room?" And he said, "No." And I said, "Okay, well, is there any way you could simulate plants in the room?" And he said, "Oh, we have this high pressure fog system in the room to add humidity." I said, "Great, turn it on." So he said, "Okay." So he flipped it on, and I stayed with him on the phone. And, about 5 minutes later, I said, "Okay, what's the temperature now?" He said, "Oh, it's dropping. It's down to 83 degrees and 82 degrees." And he was trying to hit something like 79 or 80 degrees. So I said, "Okay, well, let's let the system keep going." And, over about 10 or 15 minutes, the temperature dropped down to 80 degrees. And he was so relieved that the temperature dropped, and of course the humidity increased. And what we were doing here, remember, when plants transpire, they are evaporatively cooling themselves and the air around them. They are converting the heat from the lights and from the air in the room into, this evaporative cooling effect. And so what you should see is that the temperature will come down in the room while the humidity increases just by having plants in the room. And so once this client saw that this phenomena was actually occurring by simulating plants in the room, I was able to sort of talk him off the ledge and convince him that the HVAC system we designed was sized appropriately once he had a full crop in that room. So again, simulating the grow room conditions will help ease everybody's mind through that HVAC startup process, to convince us all that the system is going to operate as we want it to. One other thing that I just want to say about HVAC startup conditions is that what everyone needs to look for are factory default settings. Again, because HVAC systems are designed, for non-plant environments usually, they have, these factory default settings for, say, a typical office space. And so that could be the temperature set points, that could be the dead bands, that could be the staging of compressors. And so something that everyone should ask their controls contractor to do is to check for those factory default settings and make adjustments to those settings based off of the mechanical design specifications and schedules for that particular room and equipment. Okay, number 8. It is really difficult to find servicing contractors to maintain HVAC equipment. There's a few reasons for this. One, again, because there's not a lot of HVAC equipment developed specifically for indoor plant environments. They're kind of all over the place, and mechanical contractors might not have a lot of experience, not only with indoor plant environments, but with the specific equipment that we are designing and specifying for an indoor plant environment. So these poor mechanical contractors just lack the experience that they need to service the equipment properly. The other thing is that, a lot of these indoor plant environments and greenhouses may be in remote locations, right? I mean, one of the reasons why, we're growing in indoor plant environments is to grow food and cannabis and products more locally to the market that we're serving. And by doing that, that might mean that we are in a location that doesn't have a lot of options for mechanical contractors, or who may be used to working with specific equipment and not, that they're really familiar with, and not these other equipment that we're bringing in to serve an indoor plant environment. So, finding someone to maintain the equipment and service that equipment that's not the grower, that may not be an on-site facility engineer, can be really challenging. And it really is important to have regular maintenance and care on the HVAC system to maintain its life, to avoid equipment failures, to catch problems early. I mean, if you think about it, mechanical equipment, an HVAC system is kind of like a car, right? I mean, you take your car in, or most people, I hope, take their car in on a regular basis, for oil changes, to just get, someone, at a service department or at a garage to put their eyes on the car, on the engine, to make sure that there aren't any problems sort of lurking around the corner that you could catch early before, you have a major, you know, breakdown on the road. The same thing goes with HVAC equipment, is that if we have a service contract, if we have regular maintenance staff, who are checking on the equipment, once a month or between harvest or every few months, you can avoid problems and failures, you can catch problems early, and you can extend the life of equipment. One of the things that I'm hearing a lot now, that the industry is sort of maturing, right? We've been sort of in this for about a decade now, is that compressors are failing, fans are failing, refrigerant leaks are occurring, and in some cases, we're seeing mechanical failures within a few months or just a year or 2 years. But the owner operators that we talk to that do this regular maintenance are saying that their equipment has lasted beyond 3 years. And I will tell you, if someone tells me that their equipment that they first installed, 4 or 5 years ago, is still working as they expected, or still working the same way as it did 4 or 5 years ago, they are winning, because that is honestly very rare. So doing regular maintenance is really important to keep that equipment running and to prevent those failures. And finding mechanical contractors and servicing contractors that can help do that work, maybe even train people on staff to do some of the interim checkups, is really important to keep your operation running smoothly. Okay, number 9. Well, HVAC is complicated and serves a lot of different purposes. Not only are we asking HVAC equipment to be able to operate, when the plants are little and when the plants are older, when the room is dry and when the room is humid, and when, there's people in the room and there's not people in the room, but it also serves a lot of purposes, right? We're not just asking HVAC systems a lot of times to just do temperature and humidity and VPD control. We're also using our HVAC equipment to deliver carbon dioxide to the indoor plant environment, right? We enrich, we stick that nozzle, that hose, that tube, right, into the supply air from an AC unit, and it enriches the CO2 through the supply diffusers and ducts. We also have air filters, right? Particle filters in the HVAC system. So the HVAC system is helping to clean the air. It's also helping to distribute that air with that supply fan, right? With the circulation of air of conditioned air into the room, and removing the hot, humid air out of the room and reconditioning it. We are asking HVAC equipment to do a lot of things. So that is another reason why HVAC is so challenging for indoor plant environments. We are asking it to do a lot of things to manage our environment. Number 10, HVAC is expensive. When I first got into designing HVAC systems for indoor farms, I would talk to growers who, you know, they would be ready to drop $50,000 on their lighting system. And yes, this is a small grow, but $50,000 on their lighting system and $5,000 on an HVAC system, thinking that they could just go down, to their local hardware store or to a local contractor and just pick something off the shelf or whatever was, the contractor had available in stock, and just throw it in the room and call it a day. But what a lot of those growers have learned through hard knocks is that they were not able to maybe not only not control temperature, but also not control humidity with such a cheap system. And not that those systems couldn't work, it's just that they weren't sized correctly. They may not have been installed, in a way that maximizes their ability to control the environment. You might not have the right sensors and control systems. And so, these growers, a lot of these growers are now saying, hey, now that we've made some money from growing and selling our crop and our product, we want to come back and we want to invest the money to get the HVAC system designed correctly and specified correctly. What I can tell you is that if the first cost of an HVAC system is for an indoor plant environment without sunlight. So you are in a warehouse or a container, right? This is not for greenhouse. Everyone should expect that the first cost of that HVAC system is going to be 25 to 35% of the budget right off the bat. And that is both for the cost of the purchasing the equipment, shipping the equipment, installing the equipment, and maybe starting the equipment. Those startup and commissioning and controls is probably an additional cost on top of just the equipment purchase and installation. The other thing is that HVAC energy use, the operating cost, is really high. Everyone is so focused on the cost, the operating cost of lighting. I get it. High pressure sodium lights, HID lighting uses a lot of energy, and it seems, LEDs could be a quick fix and drop the lighting energy use by 30 or 40%, just through, just distributed power, basically. But remember, we're using the HVAC system to remove the heat that the lights are producing and to remove the moisture that the plants are generating through transpiration. And so if you expect that the lights run 40 to 50% of the energy budget of your indoor farm, you can probably assume that the HVAC system is about the same. And it is. It runs between 35 and 45% of the total energy use in an indoor farm. And a lot of growers who do measure and monitor their energy use will say that after lighting, HVAC energy use is the second most energy intensive operation in their farm. And growers will also tell you, owner operators will also tell you that energy is the second most expensive line item in their operating budget after labor. So, in a nutshell, HVAC is expensive, both in terms of purchase, installation, startup, and commissioning, but also in operation. And so finding energy efficient strategies to operate the HVAC equipment so it uses less energy will save you money, as will designing and specifying the right size HVAC system. Because, they're, again, going back to number one, which is engineers don't know plants or humidity. Because of that, what we see is that a lot of mechanical design engineers oversize the HVAC equipment because they don't understand the evaporative cooling effect that plants have on the environment, or because they build, we engineers, we love to build safety factor onto safety factor onto safety factor so that we have a 25% safety factor on top of what we really needed, 99.5% of the time. And so, if you install an oversized piece of equipment, not only could you have a lot of cycling of that equipment on and off and not a very stable indoor plant environment, but every time those motors kick on, they're using more power, they're using more energy to cool and dehumidify and distribute air to that indoor plant environment. So, finding energy efficient strategies, designing the HVAC system correctly, and not building in too big of a safety factor can help reduce both the first and operating cost of your whole facility. Okay, so as a recap, 10 reasons why HVAC for indoor plant environments is so hard. Number one, engineers don't know plants or humidity, at least not very well usually. Number two, growers don't know HVAC systems, and we shouldn't ask them to be HVAC engineers. Number three, plants aren't people. Well, we're definitely not going to ask plants to become people. We love them as they are. And so we need to be the ones who are paying attention, listening to, and responding to the plant's needs. Number four, HVAC equipment is not specifically designed for indoor plant environments. They're really good at controlling the temperature, but not so good at controlling humidity. And they are slow to respond. Number five, indoor plant environments are dynamic. Plants are growing from small to large. Growers are changing their operating schedules. There are different room conditions, there are different lighting conditions, and we are asking the HVAC equipment to manage an environment that is always changing. Number six, controls are limited in their ability to manage the indoor plant environment. Horticultural control systems are great at irrigation management and on-off controls at some variable speed schedules, but they're not necessarily good at speaking the same language as commercial HVAC equipment. And on the flip side, building management systems that do speak the language of commercial HVAC equipment are not very adept at being able to speak irrigation and nutrient management. Number eight, it is really difficult to find servicing mechanical contractors who are familiar with the equipment and who are local to where the indoor farm is. Number nine, HVAC is complicated. It serves many purposes. It's managing temperature, humidity, vapor pressure deficit, carbon dioxide, air distribution, air filtration, and air quality. We are asking this one system to wear many hats, just like the farmer, and that is really hard to find a good fit for all of these indoor plant environments when we're asking it to do so many things. And number 10, HVAC is expensive. It is both expensive to buy, to start up, and to operate. So designing the right system that is sized specifically for your indoor plant environment and implementing energy efficiency strategies like staging and variable speed components and maybe using outside air when the weather permits can save on operating costs. And every owner operator who is going to design a new facility should just expect that the HVAC system is going to comprise 25 to 35% of your capital budget. Okay, so that is the end of this episode of The Doctor Is In. Thank you so much for listening in. Please contact us if you have any questions or thoughts. I'm your host, Dr. Nadia Saba, president of Dr. Greenhouse, and I will talk to you next time. Thanks.